A game consists of black and white pieces. The number of black pieces is 5 more than 3 times the white pieces. 7 white and 15 black pieces are removed each round. After several rounds, there are 3 white and 56 black pieces left. How many pieces were there in the beginning? Solution. Let B and W be the number of black and white pieces in the beginning respectively. The number of black pieces is 5 more than 3 times the white pieces. Therefore, B equals 3W plus 5, equation A. Let the number of rounds be x. Number of white pieces removed in one round equals 7. Number of white pieces removed in x rounds equals 7x. Number of white pieces left at the end of all rounds equals 3. Therefore, total number of white pieces at the beginning of the game W equals 7x plus 3, equation B. Similarly, number of black pieces removed in one round equals 15. Number of black pieces removed in x rounds equals 15x. Number of black pieces left at the end of all rounds equals 56. Therefore, total number of black pieces at the beginning of the game B equals 15x plus 56, equation C. Substituting the values of B and W into equation A and finding the value of x. 15x plus 56 equals 3, 7x plus 3, plus 5. 15x plus 56 equals 21x plus 14. 6x equals 42, x equals 7. Now, finding the number of black and white pieces in the beginning. W equals 7 multiplied by 7 plus 3 is equal to 52, using equation B. B equals 15 multiplied by 7 plus 56 is equal to 161, using equation C. Therefore, total number of pieces, W plus B equals 52 plus 161 is equal to 213. There are 2 plants in Mrs. Samia's garden. One is 44 centimeters tall, and it grows 3 centimeters every 2 years. The other is 80 centimeters tall, and it grows 5 centimeters every 6 years. In how many years will the 2 plants have the same height? Solution. First plant height is equal to 44 centimeters. It grows 3 centimeters every 2 years. So in 1 year it will grow 3 by 2 centimeters. Therefore, in n years it will grow is equal to n multiply 3 divide 2 is equal to 3n divide 2 centimeters. Hence, the height of the first plant after n years will be is equal to 44 plus 3n divided by 2 centimeters. Second plant height is equal to 80 centimeters. It grows 5 centimeters every 6 years. So in 1 year it will grow 5 divided by 6 centimeters. Therefore, in n years it will grow is equal to n multiply 5 divided by 6 is equal to 5n divide 6 centimeters. Hence, the height of the second plant after n years will be is equal to 80 plus 5n divided by 6 centimeters. Let both plants have equal height after n years. Therefore, 44 plus 3n divided by 2 is equal to 80 plus 5n divided by 6. 88 plus 3n divided by 2 is equal to 480 plus 5n divided by 6. 3 bracket 88 plus 3n is equal to 480 plus 5n. 264 plus 9n is equal to 480 plus 5n. 9n minus 5n is equal to 480 minus 264. 4n is equal to 216. So n is equal to 54. Therefore, both plants will have equal height after 54 years. A snail fell into a hole that is 10 meters deep. Every day it would climb 3 meters up, but then it would fall 2 meters down while sleeping during the night. After how many days would the snail climb out of the hole? Solution: depth of the hole is equal to 10 meters. The depth the snail climbs up during the day is equal to 3 meters. The depth it falls down at night is equal to 2 meters. Therefore, the total depth it covers by the end of one complete day, including night, is equal to 3 minus 2 is equal to 1 meter. Hence, after 7 complete days it will climb up 7 meters. The next day it will climb up. 7 plus 3 is equal to 10 meters. Notice that it does not slip down because it has already come out of the hole before the night starts. Therefore, the snail takes 7 plus 1 is equal to 8 days to climb out of the hole.
A tournament had 6 players. Each player played every other player only once, with no ties. If Helen won 4 games, Inez won 3 games, Janet won 2 games, Kendra won 2 games, and Laura won 2 games, how many games did Monica win? To determine the number of games for a single round-robin tournament, we use the following formula: n multiplied by n minus 1 divided by 2, where n is equal to number of teams players. Since there are 6 players in this tournament, total number of games played will be 6 multiplied by 6 minus 1 divided by 2 is equal to 6 multiplied by 5 divided by 2 equal to 30 by 2, which is then equal to 15 games. Given Helen won 4 games, Inez won 3 games, Janet won 2 games, Kendra won 2 games, and Laura won 2 games. Since there are no ties, one person wins from each game. Therefore, total number of games finished is equal to 4 plus 3 plus 2 plus 2 plus 2 equals 13 games. Therefore, Monica needs to win total number of games minus number of games finished is equal to 15 minus 13 equal to 2 games.
When wheel B rotates 2 times, wheel A rotates 6 times. When wheel A rotates 42 times, how many times would wheel B rotate? Let's denote the number of rotations of wheel B as X and the number of rotations of wheel A as Y. The given information can be expressed as a ratio. Rotations of B by rotations of A is equal to X by Y, which is equal to 2 by 6, since wheel A rotates 6 times, when wheel B rotates 2 times. To find the ratio when wheel A rotates 42 times, we can set up a proportion. Rotations of B by rotations of A is equal to X by 42, which is equal to 2 by 6. Now, we can cross-multiply to solve for X. 6 times X equals 2 times 42, which implies 6X is equal to 84, which implies X is equal to 14. Therefore, when wheel A rotates 42 times, wheel B would rotate 14 times. The seats on a children's merry-go-round are labeled 1, 2, 3, and so on. On the merry-go-round, Adam was sitting on seat number 2, exactly opposite Mark, who was sitting on seat number 7. How many seats are there on the merry-go-round? Since Adam and Mark are sitting exactly opposite each other, the seat numbers between them in one direction are 3, 4, 5, and 6. Therefore, total number of seats between them on one side is equal to 4. Since it is a merry-go-round, number of seats between them in other direction also has to be the same, which is 4. Therefore, total number of seats in the merry-go-round is equal to 10, including Adam and Mark. 4 students can sit around a square table. Students placed 10 square tables side by side in order to make one long table for a school party. How many students could sit around this long table? Since 10 square tables are placed side by side next to each other, 3 people can sit at each of the 2 end tables. Therefore, number of people sitting at the 2 end tables is equal to 2 times 3, which is equal to 6. Now, at each of the remaining 8 tables in the middle, only 2 people could sit across each other. Therefore, number of people sitting at the 8 middle tables is equal to 8 times 2, which is equal to 16. Hence, total number of people who can sit around these 10 tables is equal to 6 plus 16, which is equal to 22. Thank you for watching.